I get applause. This is awesome. Already feeling amazing. So I'm not going to spend any time talking about me, my awkwardly long title, weird company name, Neo4j. Because most likely all of you can read. There was like semi a question, can you read? Of course you can. So we're not going to spend time about that. If you just wander in here with no clue wherever you are, actually that's a good thing because the network around you is actually the stronger predictors of your behavior. And I'm going to talk a little bit about that because for me, that is just a graph problem. Do you have a graph problem? OK, again, so when I do a question, I'm going to do like this, so you know it's a question, so it's not awkwardly silenced. Do you have a graph problem? Oh, yes, I wasn't expecting that, but that's a good thing. Sales guys, go upstairs. They're up there. I saw them somewhere around here, and there's a guy over there. Cool, so most people, they don't actually know they have a graph problem. This is one of the fundamental problems we at Neo4j had for a very long time, so much that Emil, our CEO, actually coined a name for this thing. We call it the graph problem. So just to get everybody up to speed, what we're going to be talking about, it's not going to be the pie chart kind of graphs. We're going to talk about graph theory, basically the mathematical structure, how things are related. So in this world, we have two components that form a graph. We're going to have nodes, which we represent by circles. We're going to have arrows that connects to other nodes, which are called relationships. If you did this in university, maybe the concept of vertices and edges would be more familiar to you. I suggest use whatever you feel comfortable with. Within a graph, we can then have directions. Sometimes it's of value. Sometimes it's not. For us, it doesn't really matter, right? It's just a thing that sometimes it helps you and sometimes it does. And now we come to the first part. So all of you that was thinking this is going to be a quiet and boring thing, run out now, because now it's time for a little exercise. Are you ready? Good. Start to warm up a little bit. Very hard to do this before lunch, right? So I introduce a little graph here. So we have two nodes and a relationship between them. And we're going to take the consumer web as an example and see why graphs are so freaking cool, right? So in one of the nodes, I write person. One of the other nodes, I write person again. And then I will give this relationship a name. And when I do so, you're going to scream out the company. Already somebody screamed Facebook. Who was that? I can't see you. Up there. Alex, can you give that man a T-shirt? Show your hand. He gets a T-shirt. Very cool. Now he thinks his life is all good. So he said Facebook. But the thing here is, if you have this in a graph, what can you answer using this? Not the most obvious question, right? But if we think of this in a graph structure and not a table structure, in a graph structure, we're able to traverse just as long as we want. We're not going to have any problems after 4, 5, or 20 hops. We can just go trillions. So if I'm a friend of Alex over there, Alex is now a friend of that guy that just have a T-shirt because he raised his voice. Maybe I'm a friend of him as well now. All of a sudden, we have people you might know. So forming a community wasn't anything new at the time, right? All of you Lunar Stormers or MySpacers or Yahoo groups, if you're terribly old and hopeless, we all know what that was, right? But the interesting part, in a graph structure, it allows for growth. And we all know how annoyingly fast Facebook grows. My neighbor's vacuum cleaner's dog added me on Facebook once, and I don't know, it was too much, right? So tremendously powerful. However, if we introduce another concept on this one, and then we do like this. Oh, classic clicker problem. Magical clicker, there we go. Very good. A person follows another person. What kind of company is this? Instagram, Alex, figure out. Whoever wants a T-shirt, raise your hand, but you have to answer a question. What can we answer using this now when we add directions to the graph? We can see influence, importance, right? You can all understand I am not cool at all. I'm just here on stage bragging and whatever crap. Alex is super important. Everybody loves Alex, right? Alex doesn't like me because I bring up his name so often in these kind of scenarios, right? So we see importance. But we can take another one, right? We can do a person that drives another person. Uber, what can we answer now? And how did this transform yet another industry? I mean, if it's just a person driving one person, that's a private chauffeur. Doesn't disrupt anything. We have that for ages. Sometimes it was also fairly racist, so don't go into that trap. But if we add millions of people that want to drive people, we add millions of people that want to be driven by people, all of a sudden, we see supply and demand here, right? If we have a structure that allows for this in real time, magic starts to happen. If we see how fast the car normally drives on that road compared to the speed now, because every single one of those have that app in there, all of a sudden we can do a pretty darn good estimate of the actual fare. Did it transform an industry because they had an app or black cars? No, because they have a backend built on a graph, being able to predict the exact price instead of taking money from you all the time. And then, of course, sometimes in New York around New Year, it escalated a little bit too quickly. It was a very expensive taxi ride I did there. But let's not talk about that one. Let's go for the next one. Are you ready? Lame people, come on now. Okay, I shouldn't be that evil. Very good people, come on now. A person transfer money to another person. Swish, now we know we're in Swedish. Do you know what Swish is? Should they get the t-shirt because they should have said PayPal or something else? No, but what can we say now when we have this? This started to become very interesting. We can see maybe criminal activity. Maybe we have some banks in here who want to talk about fraud and those kind of things. But we can also see how things connect and transactions that were basically possibly unknown before, right? And to the magical graph that I know all of you use very often, a person that searched for something is, of course, yes, that's a magic answer. It's a good thing you didn't say Lycos or Alta Vista or whatever they were called back in the days. Because think of this. Think of how it was to search on the internet before. I see some old people, so this is directed to you guys. Young people, just ignore it. This is a history lesson from the old. It was based on keywords, right? So not only did I know how to spell it, also I'm pretty crap at English, so I needed to spell it right. But then Alexander, he's German. He can't spell in English either. So I need to figure out how he spelled it on the other side of the internet. And when we got those misspelled results, they weren't ranked in any way. So I usually ask this question. Did Google have a graph problem back in the early 2000s? I would say they actually had an information retrieval problem. And the thing was that they kind of looked upon it from a kind of different angle. So they said that the authority value of a web page is based on the authority values of the web page linking to it, right? It was the foundation of PageRank, a magical graph algorithm, super important, and basically transforming how we use internet in that sense. So as you can see, I need to go and see on that side. So B here is super important. This is Alex, my friend. Everybody loves him. You know, everybody points to him, so he become a big circle. However, Alex actually, like me, I'm C there. So I'm the introvert in the class, being adopted by an extrovert. Maybe it's the other way around here. That's why I'm on stage, but nevertheless, that's the case. So then my popularity as he grows, right? Just magical. And by doing that, the consequences became a market leader in search. But the pretty neat darn thing that they did, that they built an ad engine, which is the most successful of all times, on top of that, right? So my ask to you is, I'm going to quote my friend Jesus Barasa, that actually misquoted another person. So this is a quote of a quote of a quote. So in a sense, that's kind of graphy as well. So ask not whatever you have a graph problem. Instead, look at your problem with a graph thinking mindset, right? It is almost like when we think of data, we see tables. We see vectors. We see these things. It's limited our mind because we're so used to putting things in table or boxes. So sometimes it's hard to understand that the world is a network, right? One of the cool things working for Neo is that we have done this kind of journey with a lot of companies for over a decade, right? For a very long time, we were alone in the space, meaning that we have a lot of history looking upon kind of a decade of learning from enterprise adoption. So that's what I studied when I joined. Could I see any clear patterns of success factors? Because I am just as you, very, very lazy. I just want to make a magical formula so I can cheat the game, right? We all that. So basically what we did was looked upon companies in transitions. This is what people also refer to as Kodak companies or dinosaurs. I just say in transition because it was very easy to fix it. And then we looked upon digital natives. And one interesting part there is that we saw that connecting basically the data silos within companies literally transform also companies itself. Because very often, I don't hate people in IT or in business. It's just that they don't get what I do, right? By combining the data, they actually start to work together in a whole other way, which is kind of super cool. And also, obviously, connected insights leads to revelations and answering questions that you couldn't even dreamed of previously. Kind of super cool, right? And the third one, which is not kind of obvious, it is super obvious if you have a background in network theory, because all of the ones that I showed you before were companies built on network effects, right? It's just as a phone. If I have a phone and the only person I can call is Alex, that's like bat phone or whatever. It's completely useless because I'm not Batman and he's not the mayor of Gotham, neither the other way around, right? But if I can call every single one of you, the value rises exponentially real quick. So what we saw that the more graphs within the company, the more value the individual graph itself had, and the individual graph itself had more value because of the network effect in that graph. So it's kind of double cake with a cake. In Sweden, it's called tårta på tårta. It's a very good phrase, right? But this time it was good. I think that phrase comes from having smörgåstårta and real cake. It's horrible. Let's not talk about that. It's a bad idea. Why did I go in there? That's what I do a lot. So they had enough of that. They were offended by the tårta joke. Okay, sorry for that. I'm not going to do that. So let's talk about this. But what I see very often is we have this kind of cognitive bias to kind of over-resilience on a familiar tool, right? The tables. So I pulled out your email addresses from your registration, and I'm going to do a little stunt here. Are you nervous? This is not that. This is an old email set, so don't worry. I didn't fill in mine. But look at this, right? We see a couple of things. So we can do a count. We can see who sent emails and such things, right? It will give us some information. Pretty darn useless. So I'm going to give you magical Kiwi graph glasses. You all have them now. Do you feel the new superpower they have? Whew, very interactive. Very good. And boom, we take the same data set and model it as a graph. Already now we start to see different things, right? We see that we have basically a cluster here and a separate cluster over here. So maybe this is IT and business that doesn't email to each other. They hate each other. No, they don't. They love each other very much. So one of the things that I use often when I starting with an unknown data set, I use something called weakly connected components or union find. It gives me these kind of subgraphs that are disjointed or outside of the graph, right? It's a good starting point to kind of start to understand the data, because very often I really don't know what I want to ask. Sometimes it's very clear. Then I just drop into the graph and traverse to whatever I want. But sometimes you just have this kind of big data crap, and you want to explore it. So this is a good starting point. However, what we can see, if we start looking this and running up a couple of other algorithms, we see that our friend here, E, has the highest between centrality. So a perfect kind of node, right? And this could be useful if you work in defense, what is that bridge leading to Stockholm that we're going to take down if we are another country or something else? If I want a connection between two kind of groups of people, who would that be? And sometimes that bridge is that thing. However, not always, because very often when we look upon influence, we do things a little bit wrong. So for that, I would actually use closest centrality, because I want to see who is close to get information out in the network. I usually use this as a metaphor of Kanye West's agent or something, because he knows a lot of people, and he's also not such a a-hole as Kanye West. So it's easier to talk to him to get information out, right? So a very cool thing, right? However, if we then add another algorithm on top of this, PageRank, we start to see directions in between. So we see, obviously, in that cluster, K is obviously super cool. But then in this other one, G pops up. So all of a sudden, this tells a whole other story than that table structure, who sent the most emails, right? We start to see how things are connected. And then we can do something which is very, very funny. We can run something that called Jacquard similarity on top of this and see how alike things are. This is a very cool feature. It also gives you a score, but it writes a relationship between things. So it will write a relationship, how alike I am like Alex, how alike I am like Thomas, and it gives a kind of value on that. The neat part with that is then taking that value, cluster it using a community detection algorithm like Louvain or something else, and all of a sudden we see behavior patterns in the way we send emails. Kind of cool. And then we can, of course, get all of these things in one. And all of a sudden, we have a whole other ball game, and we play at a different level. Because if we can see this in real time and act upon this in real time, we see things differently. And I think this is why I love graphs, because it allows me to get better prediction with the data I already have, right? So relationships are highly predicted, right? Very often, they are, however, ignored in most other normal cases. Very often, every single kind of machine learning approach is based upon a tabular approach, which makes it very hard. That's why we sometimes have a hard time getting to that phase of general AI, right? We're very good at the specific domain, but as soon as it gets to reason around context, yeah, I would argue. So I would use something called, for that case, embeddings, basically taking your graph. You can take a node, the entire graph, or a part of it, or any path, convert it into a vector, and then run it in your existing machine learning pipeline. So basically what I would argue is, to graph or not to graph is not the question, because we live in a world where clicker doesn't work, and I get very annoyed. But however, it's all connected back to myself, right? So everything is naturally connected in the world. It's a very rare occasion to see tables in the nature. You can see it flying in over Amsterdam the other day. I saw beautiful tulip tables, but not that often, right? So if you are an organization that do understand this, you have advantage. However, yes, if you fail to see this, you are working in a paradigm where it's going to be very, very hard, right? Sometimes I think of this, I talk about, you know, the competition between Tesla and Volkswagen. If it takes 1 hour to do a car for Tesla, it takes 3 hours for Volkswagen. It's not that, but the scale is the same. So this kind of connected world require a new way of thinking, and we see this all over, and very often being out here, that was a fun part of doing the talk this late of an event, because people go out like, what is this Neo4j thing? Why don't people talk about this? I think the reason for that is not that people are not using it, because every single one are using it. Like, it's all over all verticals. We got the largest founding in a database history. It's the fastest growing category in DB engines. Gartners and their likes are overhyping this. So I think the reason why you don't hear this is the classical reason. A lot of people actually are working on it, but it's a very competitive, is the disruptive game they do, so they don't want to tell you. But if you want to know more about graphs, there's a graph here. I got my colleagues over here. We're all connected. If you got a T-shirt and it's the wrong size, just go outside. There might be a right size there, so you don't have to wear like a, magtröja or whatever that's called. But that's all for me. Now it comes up a sign, very red, aggressive, screaming, overtime. So I'm going to stop here, and I want to thank you for being with me here today. So thank you.